Hello and welcome to our mathematics lesson. We are now finalizing on our topic on quadratic expressions and algebraic fractions. And during this lesson, we like to finalize by looking at equations that involve algebraic fractions. During our past lesson, we were able to discuss on how we can be able to simplify algebraic fractions by use of addition and subtraction. We said that whenever you want to either add or subtract algebraic fractions, then you first look for the LCD or determine the LCD of the denominators. Then you rewrite the two fractions using the new LCD or the least common divider or the least common denominator. Then you finally either add or subtract the numerator. We have been able to look at an extensively how you can be able to simplify such quadratic expressions, both simple and complex quadratic expressions. So now welcome to our last section, where we now want to look at equations that involve algebraic fractions. Then later we do the summary of the whole topic. Now, whenever the term equations come into your mind or into play, then we should be able to recall that it is defined or derived from the term equal. That means we have introduction of equal signs. Now, for us to be able to solve a particular equation or algebraic expression, then we need to know how we can be able to simplify those particular expressions. We have a few points here of concern. For equations with more than one fraction, multiply both sides by the least common denominator, that is the LCD. And in that particular case, we multiply each entry, multiply every term. That is every term in that particular equation on both sides, not just one term, not just the fractions, because there are sometimes you'll be tempted to only multiply the fractions alone. You must multiply on every term. If there is a term that is not a fraction, multiply by that least common denominator. Another, simplify the fraction. We simplify the fraction and solve the equation. And you solve the equation using any method that we learned earlier on. There's an alternative method. Alternatively, convert all the expressions in the equation to fractions with a common denominator, then equate. Then you finally equate the numerators. We are going to look at how this particular solution will come into play. You can alternatively convert all the expressions in the equations to be fractions that consist of the same denominator. That means you come up, or after finding a common, the least common denominator, you express all the fractions in that particular expression or equations in terms of the new LCD that you'll have gotten, or the new denominator. We now want to look at another number of examples on how we can be able to solve such problems or equations. Example 1. We are told solve each of the following. Equations. Number 1, we have 2x over 3 plus x over 2 is equals to 7. So let us solve each one step by step. Now, using the first method, method 1, we said we multiply every term in this particular fraction equation using the least common denominator. In this case, 7 can be written as 7 over 1. Now, the least common denominator of 3 and 2 is going to be 3 multiplied by 2, which is 6. So that means you're going to multiply every term in this particular equation by 6. So that means you multiply the first term by 6, you also multiply the second term by 6, you also multiply the right hand side by 6. That's why we said you must multiply, whether it's a fraction or not a fraction, you must multiply by that common denominator. So this 3 there once, 3 goes into 6 twice, so this will be 2 multiplied by 2x, which will give us 4x, plus 2 there once, 2 into 6 thrice, 3 multiplied by x is 3x, is equals to 7 multiplied by 6 will give us 42. After doing that, you'll discover that we have pairs which are like terms, so we add them together. 4x plus 3x will give us 7x. So this will be 7x is equals to 42. After finding the value that 7x is equals to 42, in solution or in solving an equation, solving means you obtain the answer to that part that is missing. So like in this case, we need to find what is the value of this x. Now for us to get the value of x, we need to divide both or through by 7. So you divide the left hand side by 7, the right hand side by 7. So this will leave us with x is equals to 7 goes into 42 6 times. So you can now be able to say that x is equals to 16. Method 2. So method 1, we look for the LCD. After finding the LCD, you multiply every term in that particular equation with the LCD. After multiplying every term with the LCD, you now proceed and solve. And as you have been able to see, we have now gotten the value of our x to be 6. In method 2, we said you express every term in the equation using the least common denominator. And in this case, we have been able to say that the least common denominator is 6. LCD is equals to 6. Now 3 goes into 6 2 times, so that means we are going to multiply 2 by 2x. That will give us 4x over 6. Plus 2 goes into 6 3 times. 3 multiplied by x will give us 3x all over the new, which is 6, is equals to 1. 1 goes into 6 6 times, so 6 times 7 will give us 42 all over the new denominator, which is 6. So at this stage you can now be able to appreciate that we have all the fractions expressed as equivalent expressions or fractions using the least common denominator, which is 6. Then that method goes further and say that you can now be able to equate the what? The numerators. So we pick the numerators, which is now 4x plus 3x is equals to 42. This will give us 4x plus 3x to be 7x is equals to 42. Now for you to be able to solve the value of x, you divide both sides by 7, and this will give you x to be 6, which is the same as what you had here. So those are the two methods which can be used. Now example 2 or B. B, we have x minus 2, all this divided by 5, subtract x minus 1, all of this divided by 3 is equals to 1. We need to solve this. Being equal to 1 simply means 1 over 1. Now method 1, we need to find the LCD of 5, 3, and 1, and the LCD is going to be 5 multiplied by 3, which means it's going to be 15. So that means we multiply each of the term with 15. So this will be x minus 2 over 5 minus x minus 1 over 3 is equals to 1. So each term is multiplied by 15. By 15, which is the LCD. Now 5 there once, 5 into 15 3 times. So this will give us 3 into x minus 2 minus 3 into 15, 5. So this will be 5 into x minus 1 is equals to 1 times 15, which is 15. Then you now move in and open up these expressions. This will be 3 multiplied by x, which will give us 3x. 3 multiplied by 2 will give us 6. 5 multiplied by x will give us 5x. Minus 5 times minus 1 will give us positive 5 is equals to 15. Then we now move in and do combine or collect the like terms. 3x minus 5x, this will be minus 2x. Minus 6 plus 5 will be minus 1 is equals to 15. We take 1 to the other side, that means we add 1 on both sides. This will give us negative 2x to be equal to 16. And this means that our x is going to be 16 divided by minus 2, which is going to be minus 8. Alternatively, and that is now method 2, where we write all these using equivalent fractions under the LCD. The LCD we have said is going to be 15. Now 5 goes into 15 3 times, so that means you're going to have 3 into x minus 2 all over 15. Subtract 3 goes into 15 5 times, so this will be 5 into x minus 1 all over 15 is equals to, we again rewrite this using LCD of 15. 1 goes into 15 times, so we multiply 15 by 1, so that will be 15 all over 15. Then at that stage, because now the denominators are the same, we can now be able to equate the numerators. And while we are equating, we want to open up. So this will be 3x minus 6 minus 5x plus 5 is equals to 15. Now 3x minus 5x, you'll get minus 2x minus 1 is equals to 15. When we take 1 to the other side, it becomes positive, so minus 2x will be equal to 15 plus 1, which is 16. That means x will be 16 divided by negative 2. That means x is going to give us negative 8. And as you can be able to see, x is equals to negative 8. Part C. Part C, we have 5 over 2x subtract 4 over 3x. The answer is 2, which can put it there to be 2 over 1. Now method 1 requires us to find the LCD of 2x, 3x, and 1. And the LCD in this case will be 2x, either 2 times 3x, which is going to be 6x. Then we multiply all through by 6x, so this will be 5 over 2x minus 4 over 3x is equals to 2. So we multiply each term by 6x. So x and x will cancel, 2 there once, 2 there 3. This will be 3 times 5. 3 times 5 will give us 15 minus x and x cancels, 3 there once, 3 into 6 twice, 2 times 4 is 8 is equals to 2 times 6x, you get 12x. Now 15 minus 8 will give you positive 7. That means 7 is equals to 12x. And now for us to be able to find the value of x, you divide both sides by 12. So that means that our x is going to be 7/12. Using our method 2, where we write these equations or each of these equations using equivalent fractions, then our LCD, we are going to still use 6x. Then when we are rewriting, this will be 5 multiplied by 3x. 2x goes into 6x 3 times, so this will be 15 all over 6x minus 3x goes into 6x twice, so 2 times 4 is 8 all over 6x is equals to 1 goes into 6x times. So 6x times 2 will give us 12x, and this is over 6x. Now because the denominators are the same, we now equate the numerator. So that will be 15 minus 8 is equals to 12x. 15 minus 8 is 7, so 7 is equals to 12x. That means that our x is going to be 7 divided by 12. Which is still the same as what we have here. Another example, part D of the question. We are told 3 over x plus 1 is equals to 2 all over x plus 4. The LCD using method 1 is going to be the product of the binomial terms, which is x plus 1 multiplied by x plus 4. So that means we must multiply the left hand side with this, the right hand side with this. So we're going to have 3 all over x plus 1 is equals to 2 all over x plus 4 multiplied by x plus 1, x plus 4 multiplied by x plus 1, x plus 4. So this will cancel with that, this will cancel with this. We are going to remain with 3 into x plus 4 is equals to 2 into x plus 1. When you expand the left hand side, this will give us 6x plus 12 is equals to 2x plus 2. Bringing 2x to the other side and taking 12 to the other side, we're going to have 4x is equals to negative 10. That means that our x is going to be negative 10 all over 4, which will give us sorry, 3 multiplied by x is 3x, so that means you're going to have 3x plus 12 is equals to 2x plus 2. So I bring 2x this side, we take 12 to the other side, so this will give us 3x minus 2x is x to be equal to negative 10. Let us use the alternative method, where we write each of the expression under the same denominator. So we are going to have our LCD as x plus 1, x plus 4. Now x plus 1 goes into x plus 1, x plus 4, x plus 4 times. So that will be 3 into x plus 4 all over the new denominator, which is x plus 1, x plus 4 is equals to x plus 4 goes into x plus 1, x plus 4, x plus 1 times. So this will be 2 into x plus 1 times all over x plus 1, x plus 4. Now because the denominators are the same, we can now equate the numerators, and when you expand, we're going to get 3x plus 12 is equals to 2x plus 2. When this comes this side, that goes the other side, we're going to have 3x minus 2x, which is equals to 2 minus 12. This will give us x to be equal to negative 10. And that means that the value of our x is a negative number, which is negative 10. Now example 2, we are told write down the lowest common denominator of these fractions. Number A, we have x over 3 subtract 2x over 5 all over 5 is equals to 1. Number B, we have got x plus 1 over 3 minus x over 6 to be equal to 5. Number C, x minus 1 all over 4 minus 3x over 8 is equals to an eighth. So in solving the first part, we need to find the lowest common denominator of this particular part. This is like 1 over 1. So it's like we're looking for the LCD of 3, 5, and 1. And in this particular case, the LCD of 3, 5, and 1 is simply The lowest one is 3. 3 goes into 3 once. This means it remains 5. The next one is 5. 5 goes into 5 once. So that means that the LCD will be 3 times 5, which is going to be 15. So the LCD of these fractions is going to be 15. Now for the second part, this is like 1. For us to be able to get the LCD, we need to find the LCM of 3, 6, and 1. So we begin with the lowest one, which is 2. 2 does not go into 3, so we remain with 3. 2 goes into 6 3 times, that is 1. The next one is 3. 3 goes into 3, 1, 1, 1. Therefore, the LCD is 2 times 3, which is equals to 6. You can still check the highest factor because 3 goes into 6, so you can just take 6 to be your lowest common denominator. Number D, we have got 4 numbers, 4, 8, and 8, and we need to find the LCD. So that means the LCD will be the LCM of the numbers 4, 8, and 8. So the least one, we begin with 2. 2 goes into 4 twice. 2 goes into 8 4 times. 2 goes into 8 4 times. The next one is 2. 2 goes into 2 once. 2 goes into 4 twice, into 4 twice. The next one is 2. That is 1, 1, 1, meaning it is 2 cubed, which is 8. So the LCD is going to be 8. Again, we can be able to discover that 8 is the highest factor. Example 3. We are told simplify the fractions by cancelling. So by cancelling, number 1, we have 12x over 3. Number B, 36 into x minus 7 into x minus 1. The whole of this divided by 9 into x minus 7. C, 4 into x plus 3. All that divided by 2. Now we need to be able to simplify this by simply cancelling. As you can be able to see, 12 divided by 3 is 4. So that means we are going to remain here with 4x. 3 goes into 12 4 times. Now in part B, x minus 7 and x minus 7 will cancel off. Then 36 and 9 has a common factor, which is 3. 3 goes into 9 3 times. 3 goes into 36 12 times. So that means you're going to remain with 12 into x minus 1. Sorry. Okay. All over 3 all over 3. You can still be able to see that 3 goes into 12 4 times, and this will leave us with 4 into x subtract 1. So that 9 is a factor of 36. 9 goes into 36 4 times. So the answer will be 4 into x minus 1. With part C, you can be able to see we have got 4 into x plus 3, all of it divided by 2. So this 2 is a factor of 4, and therefore 2 goes into 2 once, 2 goes into 4 twice. So that means you're going to have 2 into x plus 3. The question simply wanted us to simplify, not to expand. Example 4. Solve each of the following equations. Number 1, x over 2 plus x over 5 is equals to 7. Just 7 over 1. Number B, five m over 3 minus m over 2 is equals to 1. And C, x over 2 plus x over 3. The answer is 10. So we need to solve these 3 questions. The first one is x over 2 plus x over 5 is equals to 7 over 1. We had said that there are 2 methods. You can pick whichever you are confident with. You can first work it out by multiplying through the LCD of 2 and 5, or you can use the other method where you convert all the fractions into fractions that consist of denominators which are the same or equivalent fractions. So let us use the first method where you multiply through by the LCD. Now the LCD of 2, 5 and 1 is going to be 2 times 5, which will be 10. So that means we multiply through by 10. That will be x over 2 plus x over 5 is equal to 7 over 1. We multiply all through by 10. So each term is multiplied by 10. 2 there once, 2 into 10 is 5 times. 5 multiplied by x will give us 5x plus 5 there once, 5 into 10 is twice. 2 times x will give us 2x is equals to 7 multiplied by 10 will give us 70. So we now have 5x plus 2x is equals to 70. 5x plus 2x are like terms which can be added, and this will give us 7x to be equal to 70. Now for us to get the value of x, we need to divide through by 7. When you divide through by 7, you'll get that the value of x is going to be 10. For part B, let us use the other method where we convert each of the fractions into equivalent fractions using the same LCD or the common denominator. So the LCD in this case is going to be 3 times 2, which is going to be 6. 3 goes into 6 2 times. 2 times 5 m will give us 10m all over 6 minus 2 goes into 6 3 times. 3 times m will give us 3m all over 6 is equals to 1 goes into 6 times. So 6 times 1 will be 6 all over the new denominator, which is 6. Now that we have achieved that the denominators are the same, we now equate the numerators, which will be 10m minus 3m is equals to 6. Now 10m minus 3m will give you 7m is equals to 6. For us to be able to get the value of m, we need to divide both sides by 7, and this will give us that m will be 6 over 7 as a fraction. Lastly, we have x over 2 plus x over 3 is equals to 10. Let us use the first method where we multiply through by the LCD. Now the LCD of 2 and 3 is going to be 2 multiplied by 3, which is 6. So that means we multiply every term by 6. So x over 2 plus x over 3 is equals to 10 times 6 times 6 times 6. 2 goes into 6 3, so this will be 3 times x, which will give us 3x plus 3 there once, 3 there, 2. 2 by x will give us 2x is equals to 10 by 6, which will give us 60. 3x plus 2x will give us 5x on the left hand side to be equal to 60 on the right hand side. Now for us to get x, you divide both sides by 5, and this will give us x x to be 15, to be 12. X is going to be 12. We consider another example, much complex one. Example 5, we are told solve each of the following equations. Number 1, we have x minus 1 over 2 plus x plus 2 all over 3 is equals to 11. Number B, we have b plus 3 all over 2, the all of this plus b minus 4 all over 3 is equals to 1. Then C, n plus 2 all over 3 plus n minus 2 all over 2 is equals to 1. Now this is a higher level algebraic fractions or equations. We need to solve them. So to be able to solve the first part, we can either use method 1 or method 2 of solving algebraic fractions. Let us use method 1, where we multiply through by the LCD of the denominators. In the first example, the LCD of 2, 3, and 1 is going to be 2 by 3, which is 6. So that means you are supposed to multiply the first, second, and the term on the right hand side with 6. So this will be x minus 1 over 2 plus x plus 2 over 3 is equals to 11. So everything is multiplied by 6. This term is multiplied by 6. This term is multiplied by 6. 2 there once, 2 into 6, 3. So this means you're going to have 3 into x minus 1 plus 3 there once, 3 there 2. This is going to be 2 into x plus 2 is equals to 11 times 6, which is 66. We open the brackets. This will give us 3x, subtract 3, plus 2x plus 4 is equals to 66. Then we collect the like terms, 3x plus 3x, that will give us 5x, minus 3 plus 4, that will give us plus 1, is equals to 66. So this will be 5x is equals to 66, subtract 1, which will give us 65. That means that our x is going to be 65 over 5, which will give us x will be 13. So the value of x in the first example is 13. In the second example, again the LCM is 6. So that means you multiply every term by 6. So this will be b plus 3 all over 2. The whole of this will multiply by 6 plus b minus 4 all over 3. The whole of it will multiply by 6 is equals to 1 by 6. So this will go there twice, and this will give us 3 into b plus 3 plus 3 there once, 3 there twice, 2 into b minus 4 is equals to 1 times 6, which is 6. So when you expand the bracket, we're going to have 3b plus 9 plus 2b subtract 8 to be equal to 6. 3b plus 2b, this will give us 5b. 9 minus 8 will give us 1 is equals to 6. Now for us to get b, we take 1 to the other side, it becomes minus, so that will be 6 minus 1, which will give us 5. So this means that our b is going to be 5 over 5, which is going to be 1. Finally, we have n plus 2 all over 3 plus n minus 2 all over 2 is equals to 1. The LCM for that again is 6. So we multiply through by 6. This will be n plus 2 all over 3 multiplied by 6 plus n minus 2 all over 2 multiplied by 6 is equals to 1 multiplied by 6. 3 there once, 3 there twice. This will be 2 into n plus 2 plus 2 there once, 2 there 3. 3 into n minus 2 is equals to 1 times 6, which is 6. When we expand each of the brackets, we are going to have 2n plus 4 plus 3n minus 6 is equals to 6. Then we collect the like terms. 2n plus 3n will give us 5n. 4 minus 6. 4 minus 6 will give us, this 4 minus 6 will give us minus 2 is equals to 6. So this means that 5n is equals to, we take 2 the other side, it changes side to be positive, 6 plus 2, which is going to be 8. So that means that our n is going to be 8 divided by 5, which is the same as 1 and 3/5. So that is how we can be able to solve those 3 questions. Let us look at another example, example 6. We are told solve each of the following equations. Solve each of the following equations. X plus 1 over 2 is equals to x over 3. Part B, x minus 2 all over 3 is equals to x over 2. And C, n plus 3 all over 4 is equals to n minus 1 divided by 2. Again, this is another pair of algebraic equations which we are supposed to solve. Now in this particular case, it is much easier. What you need to do is simply multiply through by the LCD. The LCD in this first case is going to be 2 times 3, which is 6. So that means we multiply the left hand side with 6, we multiply the right hand side with 6. Whatever you do to the left hand side, you must also do it to the right hand side. So this is going to be x plus 1 over 2 multiplied by 6 is equals to x all over 3, again multiplied by 6. So 2 there once, 2 there thrice, so this will give us 3 into x plus 1 is equals to 2x. When we expand this, we are going to get 3x plus 3 is equals to 2x. We bring or we collect the like terms together. When this one comes this side and this one goes the other side, they change sign. So we're going to have 3x minus 2x, which will give us x to be equal to negative 3. When negative 3 crosses the equal sign, it changes the sign to become negative. For part B, the LCD again is 3 times 2, which is 6. We need to multiply the left hand side with 6. We need to multiply the right hand side with 6. So this is going to be x subtract 2 all over 3 multiplied by 6 is equals to x over 2 multiplied by 6. 3 there once, 3 into 6 is twice, so this will be twice x minus 2 will be equal to x times 3, which is 3x. When we expand this, we are going to get 2x minus 4 to be equal to 3x. When you collect the like terms together, this comes this side. We take 4 to the we take 2x to the other side. So we shall remain with negative 4 is equals to 3 minus 2x, which is going to give us x. So that means that our x is going to be negative 4. Lastly, in this question, n plus 3 all over 4 is equals to n minus 1 over 2. What is the LCD here? The LCD is the highest factor, which is 4, and 2 is a factor of 4. So in this particular case, we are going to multiply through by 4. This will be n plus 3 all over 4. The whole of it is multiplied by 4 is equals to n minus 1 all over 2. The whole of it is multiplied by 4. 4 and 4 will cancel, leaving you with n plus 3 being equal to 2 there once, 2 there 2. 2 times n is 2n, subtract 2. So when we group the like terms together, we bring 2 to this other side, we take n to the other side. We're going to have 3 plus 2, which is going to be 5, is equals to 2n minus n, which is n. So that means that our n is going to be positive 5. Consider another example 7. We are told solve each of the following. Number 1, we have 3 over 4x, 3 over 4x minus 1 over 2x is equals to 4. B, 2 over 3x minus 1 over 2x is equals to 2. And then C, 4 over 2m minus 2 over 5m is equals to 3. Now for us to be able to solve this, we need to find the LCD of 4x, 2x, and 1. And in this particular case, the LCD, because 2x can go into 4x, we pick the highest factor, which is 4x. So the LCD is going to be 4x. Then that means we multiply all through by 4x. So this will be 3 all over 4x minus 1 all over 2x is equals to 4 times 4x times 4x times 4x. So this will leave us with 3. Subtract. That will be 2 to be equal to 4 times 4, which will be 16x. 3 minus 2 is 1, so that means 1 is equals to 16x. To be able to get x, you divide both sides by 16, and that will give you the value of x to be equal to a 16th. Number 2, the LCD of 3x, 2x, and 1x is going to be 6x. That is, you take 3, you multiply by 2x, that will be 6x. So that means you're going to multiply every term by 6x. 2 over 3x minus 1 over 2x is equals to 2. Every term is multiplied by 6x by 6x. This will cancel, leaving us with 2. That will be 2 multiplied by 2, which is 4. This will give us 3 is equals to 2 times 6x, which is 12x. 4 minus 3 is 1 is equals to 12x. That means for you to get the value of x, you divide both sides by 12. Therefore, our x is going to be a 12th. In the last part, we are having 4 over 2m minus 2 all over 5m is equals to 3. The LCD of 2m, 5m, and 1 is going to be 10m. So we multiply through by 10m. This will be 4 all over 2m minus 2 all over 5m is equals to 3. So every term is multiplied by 10m, 10m, 10m. M and M cancels, 2 there once, 2 into 10, 5. 5 by 4, you get 20. Subtract, M and M cancels, 5 there 1, 5 there 2. 2 by 2 is 4, is equals to 30m. 20 minus 4 is 16, so this means 16 is equals to 30m. For you to get m, you divide through by 30. That means m will be 16 all over 30, which can be simplified to 8 over 15 as your answer. That's 8 over 15. 8 all over 15. Example 8. We are told half of a number x added to 1/3 plus 1/3 of the same number is equal to 4. Is equal to 4. The question is 1. Write an equation. Write an equation describing the situation. Part B. Solve the equation to find the number. So this is a very interesting question, which is a statement question that requires us to find a number x, where you have been told that a half of this number x added to a third of the same number, the result is 4. So when we are asked to write an equation that describes this particular situation, it's quite easy. The number is x. So when you take a half of that number x, you'll get a half of x. We are told the number, a half of an x is added to a third of the same number. That means a third of the same number, which is x, and the result is going to be 4. You are through with the first part. The second part requires you to solve this particular equation. This is the same as having x over 2 plus x over 3 is equals to 4 over 1. We can decide to use method 2, where you rewrite this expression with all the fractions having the same denominator. The denominator or the LCD is going to be 2 by 3, which is 6. So this is going to be 2 into 6 is 3, that will be 3x. 3 into 6 is 2 plus 2x, and this over 6 is equals to 1 into 6 is 6. 6 by 4 is 24 all over 6. Now after achieving and having the denominators being equal, you can now equate the numerator, which will be 3x plus 2x is equals to 24. That means 5x is going to be 24. And therefore, for you to be able to find the value of x, you need to divide through by 5. That means your x is going to be 4.8. So when you take a half of 4.8, which will be 2.4, and you add a third of the same number, 2.4, the result is going to be a 4. Now this particular example brings us to the end of the discussion on the whole topic on the concept of quadratic expressions and algebraic fractions. In the topic, we were able to cover a number of aspects. One, we looked at how we can be able to carry out expansion. It's very much important on how to be able to carry out expansion. Example given, if you have 2 into x plus 6, when you expand this will be 2x plus 12. We were also able to come up or observe the difference of two squares and how it comes into play. So that if you have an expression a plus b, a minus b, the result will be a squared subtract b squared. We're also able to look at other perfect squares, like if you have a plus b and the whole of it is squared, the result will be a squared plus 2 twice plus twice the product of a and b plus b squared. What if you change this side to be negative so that you have a minus b squared? It again gives you a perfect square, which will be a squared subtract 2ab plus b squared. Only the sign here changes. 3, we have been able to look at algebraic fractions. 2x over 6 is a good example of an algebraic fractions, and we have looked at several ways in which you can be able to simplify algebraic fractions by multiplication, division, addition, and subtraction. We have also been able to look at trinomials, which we said we have got monic trinomials and non-monic trinomials. Monics are of the form x squared plus bx plus c, while non-monics are of the form x squared plus bx plus c. And we saw how each one of them can be factorized. We have also looked at factorization of different quadratic equations. And finally, we have been able to look at algebraic equations where an equal sign is introduced. And we have said that for the algebraic equations, there are 2 methods in which we can be able to use to solve. The first method is by multiplying through all the terms by the common, lowest common or the least common denominator. Then you proceed to solve. And the other method is by rewriting all the fractions in that particular expression as using the same denominator, then going on and equating the numerators. This now brings us to the end of this particular topic. Next time when we meet, we shall make an introduction and begin a new topic. Thank you.